In recent decades, the production of goods and services has been increasingly fragmented, and this is a vertical fragmentation where the product's process is being broken down into multiple stages, and the intermediate and final goods are being sourced from multiple suppliers, sometimes in different countries. And this generates spatial separation in the geographical location of energy extraction, the multiple stages of production, and final demand, which makes strict climate policy increasingly difficult. And this is commonly due to issues like carbon leakage, where production may move abroad to avoid strict local policy. And so I'm looking at trying to design an effective climate policy that accounts for this carbon and energy leakage better. So I begin with data on global input-output tables, which tracks trade across countries in multiple industries, and I've extended this data with extraction of fossil fuels. And with this extended I/O tables, I'm able to compute the energy embodied in trade flows between countries. So this accounts for all the energy in the products at their current phase of production and the trade of that. And once I've computed these flows, I'm able to generate a network where the nodes represent countries and the edges are weighted by the amount of energy in the products traded between the countries. So with this network, I'm trying to identify countries that are more or less important. So I turn to different types of network measures to try and determine where the most effective place to implement policies may be. So I begin with just our preliminary results, which is looking at various centrality measures to determine where what countries may be most important in these flows of energy throughout the globe. And we find consistently a few countries tend to be high on these centrality measures, not only in the different measures, but also across multiple fuel types, because we generate these networks for various fossil fuel types, including coal, oil, natural gas, and the aggregate. And interestingly, it's common across the different fossil fuel types as well. So, yeah.